Good morning, all you fantastic fours out there. Welcome back to a maths lesson. We've actually finished up with fractions, and so today we're going to look at a different topic. But before we do, I just want to check in to see how your times table challenge is going. Have you been practicing? Have you been getting quicker? Do you have a challenge for me? Say, send in an email and say, Mr. Travis, I've managed to do my 6 times table up till 6 times 12 in just 8 seconds. See if you can beat that. And I'm happy to give it a go in the next lesson. Okay, so let's jump across to our lesson. A reminder that if you have any questions or you want to send me what your challenge time was, you can email me at grade4@worksheetcloud.com. I'll get back to you either on the email or answer your question on the next lesson. After the lesson, if you'd like to click on the worksheet above, you can check to see how well you've managed to understand what it is we've done this lesson, and the answers are there as well. Before I even get into what our next lesson is about, I think let's quickly go through last lesson's homework. Just very quickly, just to make sure that you were on track and that we can wrap up with fractions and all is done. Okay, so solve the following and be careful to check whether you're doing plus or minus. I did say yesterday that I'm mixing them up because I want to make sure that you don't get into the trap of always doing the one or the other. So we practiced last time when the denominators are the same, we don't need to change anything. We keep our denominator the same, so the denominator stays as 5, and then we simply subtract our numerators. So 4 minus 1 is 3, so there is your answer for the first one. Looking at the second one, and please taking note that this one is actually a plus problem, not a minus one. Our denominators are already the same, so we don't need to change it. 5 plus 2 is 7. There's our answer. The third one, also with the same denominators already, also a plus. Denominator stays as 8. So 3 plus 4 is 7. Here we go. Next one, the last one where I gave you the denominators the same. So the denominator stays at 6. It's a minus problem or a subtraction problem. So 5 minus 4 is 1. So our answer is 1/6. In the next one, the denominators are not the same. So before we add or subtract, we need to make sure that the denominators are the same. So I noticed that 2 can become a 4 if I times that by 2. And what I do to the bottom, I do to the top as well. So the new fraction on the left is 1 times 2 is 2. 2 times 2 is 4. The other one I'm going to write in black. It doesn't change. 1/4. Please also note that I didn't change the order, so the one that came first still comes first, and the one that came second still comes second. Now that my denominators are the same, I can add them. Subtract them. The denominator stays the same. 2 minus 1 is 4, so my answer is 1/4. If denominators are different, so before I do anything, I need to add them. Sorry, not add them, I need to change them to be the same. So I notice that 3 is in the 4, 12 is in the 3 times table. So when I times this one by 4, I can get it to 12. What I do to the bottom, I must do to the top. So the first fraction stays the same, unchanged, in the same place. Oh my goodness. Writing in the wrong problem there. First one stays the same. Here we go. And the next one is the one that changes. And 2 times 4 is 8. 3 times 4 is 12. It's a bit messy, but I hope you can see it. Our denominators now stay the same. They stay as 12. 1 plus 8 is 9. And there's our answer. Next one, denominators are different, so before we do anything, we need to change them. I notice that I can times that by 2, and I'll get 8 at the bottom. And now I'll get a 4 at the top. The other one stays the same. 8's at the bottom. 4 minus 1 is 3. Done. Last one. I hope you've done well so far. Notice I can make this into a 12 by timesing by 3. As I've said before, the better your times tables are, the easier it is to notice. Otherwise, you can count in 4 till you get to 12, 4, 8, 12, and you can see you times it by 3. So the new numerator is 3, the new denominator is 12, so it's an equivalent fraction. Other fraction is just rewritten, not changed. Now that they're the same, I can add them because it's a plus sign. 3 plus 1 is 4. Here we go. All right, so that was yesterday's homework. Looking at fractions. I hope that you're more comfortable with fractions now. It is one of those topics that gets easier with practice, and you will revisit it pretty much every year for the rest of primary school, but each time getting a little bit harder. So just a reminder, if you had any problems with fractions and you want me to go over something either with you or with everyone else, depending on what the question is, I'll see what I can do to help. Just email me on that email address. Okay, on to today's lesson. Multiples, factors, primes, and composites. This is really just 4 words that refer to things in math that we need to understand. And yeah, so first we're just going to go through what multiples and factors are, and then how to find factors, and then we'll look at what primes and composites are, or prime numbers and composite numbers. Yeah, our lesson goals: understand what factors and multiples are, so basically just know what they are. I'm sure you have some idea of how to get them, you just may not have known what the words were. And be able to find the factors of a number, and finally to understand what prime and composite numbers are. Okay, multiples and factors. On the left, all about multiples. On the right, all about factors. So multiples. Multiples are numbers in the times table of something. So if I was looking for multiples of 6, that just means anything in the 6 times table. So 6, 12, 18, 24, 30, 36, 42, 42, 48, 54, 60, 62, 70, 66, 72, 600, anything that's in the 6 times table is a multiple of 6. There are many multiples for any number. It doesn't matter how big the number, there are multiples. So you could say 1,000. What are the multiples of the 1,000? 1,000, 2,000, 3,000, and so on. What's the multiple of a million? 1,000,000, 2,000,000, 3,000,000, and so on. Okay, so there's many multiples for any number, but just understand that it means it's something in that number's timetable. And the ways you might be asked about multiples, you might be asked a question like, is 72 a multiple of 6? So you'd need to know that 72 is in the 6 times table, which it is. So yes, it is a multiple of 6. You might be asked, is 70 a multiple of 6? And then your answer would be no, because it's not in the 6 times table. Write down a multiple of 7. That is an even number. So now we've got 2 conditions. First of all, it must be in the 7 times table. And secondly, it has to be an even number. So 7 is in the 7 times table, but it's not an even number. It's an odd number. 14, yes, there we go. So it's in the 7 times table, it's a multiple of 7, and it's an even number. So there's lots of ones. 28 is a multiple that's also even. There are different ones, but it's just giving you 2 conditions. It's really just checking that you understand what multiple is. And the third way, you might be asked to write down a number that is a multiple of 6 and 7, and that means it must be in the 6 times table and the 7 times table. So the easiest way to do that is to find the first number that is in both, or you can times them together. So in fact, the answer to 3 is 42, or there are others, 84 and higher, but the smallest one you'll find is 42. It's a number that's in the 6 times table and in the 7 times table. Okay, so multiples starts with M, and I like to think multiples make up a number. So 12 is made up of 6s. So I always remember multiples make up a number. Factors. Factors are whole numbers that fit into something exactly. Numbers that have the number you're looking at in their times table. In other words, and I use factors starts with an F and fit in. So if I'm looking for factors of 6 in the example, that means any number that fits exactly into 6. So 1 fits in exactly, 2, 4, 6. 2 fits in exactly, 3 fits in exactly, and 6 fits in exactly. So the factors of 6 are all those numbers that fit exactly into 6. So it must be a whole number, and it must fit in exactly. So you can't say 1.5 because it's not a whole number, even though 1.5 would fit into 6 if we were doing it. So factors fit in and multiples make up. All right. Some numbers have only 2 factors, others have many. Ways you may be asked about factors: list the factors of 10, which we're going to show you how to do. So that's all the numbers that fit exactly into 10. So 1 fits in, 2 fits in, 5 fits in, and 10 fits in. That would be all the numbers that fit into 10. You might be asked the question, is 5 a factor of 14? Or you might be asked, how many factors does 24 have? So in the second one, is 5 a factor of 14? That's asking, does 5 fit in exactly to 14? It doesn't, so it's not a factor of 14. And how many factors does 24 have? So you'd have to work out how many numbers fit exactly into 24. I'll show you how to do that now. Focus on factors. This is now where we're going to look at ways to find out what the factors of a number are. I'm going to show you 3 different ways. First of all, working from your head, then factor rainbows, and finally the one that I think is the most simple, or the one that I've found works best for me. And remember, you must always find the way that works best for you. Factor trees is the one that works best for me. So let's go to the whiteboard and I'll show you how to do each of these. So the first way I'm going to show you is in your head. And the first one I'm going to look at is 16. So the way that I'm going to find the factors of 16 in my head is I'm going to go through numbers until I find all of the ones that go into 16. And I'm going to do it in a logical way. I'm going to start at the beginning. So I'm going to go, well, does 1 fit into 16? Yes, 1 fits into everything. So 1 is a factor of 16. Does 2 fit in? And then I'll check in my head, 2, 4, 6, 8, 10, 12, 14, 16. Yes, 2 fits in. So 2 is a factor of 16. What about 3? 3, 6, 9, 12, 15, 18. Nope, 3 doesn't fit in exactly. Let's try 4. 4, 8, 12, 16. Yep, 4 fits in exactly. What about 5? 5, 10, 15, 20. Nope. 6, 6, 12, 18. Nope. 7, 7, 14, 21. Nope. 8, 8, 16. Yes, 8 fits in exactly. Does 9, 9, 18. No. 10, 10, 20. No. 11, 11, 22, no. 12, 12, 24, 13, no. 14, no. 15, no. 16, yes. All right. So that's where knowing your times tables is quite useful. I do want to point out something, which I'm going to just do by underlining that. Then I'm going to do a couple more, and you will see something, or hopefully you'll notice something. So the next one I want to do is 20. So 1 fits in, yes. Does 2? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, 2 fits in. 3, 6, 9, 12, 3 doesn't fit in. 4, 8, 12, 16, 20. 4 fits in. 5 fits in. 6 doesn't. 7 doesn't. 8 doesn't. 9 doesn't. 10 does. 11, no, and the next one is 20. All right, so that's relying on you to know your times tables quite well. It's not a bad method. I just think it's a little bit of a slower method to go about it. So just take note of the ones that are underlined there. And now we're going to go on to the second method, and that is factor rainbows. So the ones I'd like to look at for a factor rainbow are 15. And then let's do 12 as well. Right, in a factor rainbow, what you're going to do is you're going to draw the arcs of the rainbow. So I'm not going to worry particularly, no, let me try do the colors of the rainbow. So I'm going to start on the inside, and I'm going to look at the pair of numbers that fit into 15. So I'm always going to start with 1. 1 fits into everything, which is what I was showing you with these underlines up here. 1 fits into all whole numbers. And I'm going to ask myself, what would I times 1 by to get to 15? 1 times 15 is 15. And there you can see the other underlines I had there. So 1 and itself fit into every single number. So 1 and 16 fit into 16, 1 and 20 fit into 20. So that's a pair. I'm going to go on to my next pair. So I'm going to see, does 2 fit in? No. Does 3 fit in? 3 fits in. And what would I times 3 by to get to 15? 3 times 5 gets me 15. So there's the next line in my rainbow. Does 4 fit in? No. Does 5 fit in? Yes, but I've already got 5 on this side, and we don't need to repeat numbers. So that's all the numbers that go into 15. So now that I've drawn my rainbow, I'll write 15, and then I'll put them in order. 1 and then 3, 5, and then 15. And those are the factors of 15. Let's do 12. And this time I'm just going to start from the next color. The color is not important. So the first one, we know 1 goes into all numbers. 1 times what gives me 12? 1 times 12. Does 2 go into 12? Yes, it does. 2 times what would give me 12? Another way of asking it is how many 2's go into 12? So 2, 4, 6, 8, 10, 12. That's 6. So 6 is the partner. What's the next one? Does 3 go in? 3, 6, 9, 12. Yes, 3 does. 3 goes into 12 4 times. Does 5? No. Does 6? Yes, but we've already got 6 over there. So that's all of our factors that go into 12. So now that we've got it, we're going to list them. 1, 2, 3, 4, 6, and 12. So it is important that when you list them in order from smallest to biggest. Right, that's it. That's factor rainbows. The reason why this isn't my favorite one is because if you're only using a pencil or a pen and it's always the same color, sometimes when you draw it, you can't always tell the spaces between. So it's easy now because I've got different colors, but if it wasn't, you wouldn't be able to necessarily tell for big numbers if it was 12 or 126 or 26 and 1. So I prefer factor trees, which is the one I'm going to show you now. Three factor trees. Okay. Once I've done one, if you're comfortable with them, well, in fact, we're going to do a few after this. So let's just do these two together. So first up, I'm going to draw, I don't know why I've chosen red, but I'm going to draw factor trees. So I'm going to draw the stump of my tree. And then inside the stump of my tree, or the trunk of my tree, I'm going to put the number that I want to find the factors for. And now I'm going to draw the branches of my tree. So the first branch. And the branch, because factors come in pairs, I'm going to draw the branches like that with a little fork at the end. So 1 fits into everything, and when a partners with it, we times it by itself. So 1 times 14 gives me 14. This times this gives me the number in the middle there. I'm going to draw another branch. Does 2 fit in? 2 fits in. 2 times what? 2, 4, 6, 8, 10, 12, 14. 2 times 7. 3 doesn't fit in. 4 doesn't fit in. 5 doesn't. 6 doesn't. 7 does, but I've already got 7. So that's all the factors of 14. So 14 has the factors 1, 2, 7, and 14. Right, last example before you guys do some yourselves. This one I'm going to do one that has a few more branches. So there's my tree trunk. My first one I start with is always 1 because 1 fits into everything. 1 times 24 because it's 1 times itself. Second branch, I'm going to try 2. Does 2 fit in? 2, 4, 6, 7. Yep, 2 does. And if we count in 2 till 24, we'll see that's 12 times 2. Does 3 fit in? 3, 6, 9, 12, 15, 18, 21, 24. Yes, it does, and it fits in 8 times. So 3 and 8 are partners. Does 4 fit in? 4, 8, 12, 16, 20, 24. It does 6 times. 4, 6. Right, 5 doesn't, 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 doesn't. 12 does, but we've already got 12. So those are all the factors of 24. So now we list them underneath in order from smallest to biggest. So you will notice, or I hope you notice, that I went 1, 2, 3, 4. Because of the way I set it up, I was looking from the smallest number to the biggest, and now I'm going 6, 8, 12, 24. So it was easy to get my order as well from doing that. Okay, I'm going to give you a few that I'd like you to draw. I will set them out and we'll have a look to see. So I would like you to do the factor tree for 2. 4, 5, 8, and then depending on how fast you're working, 16 and 13. Right, get started with that. I'm going to give you a little time to go. I always start with 1. It's the one that goes into everything. Give it a chance, and if eventually when I get started again, if you haven't managed to finish them, then just pause the video and wait and finish them, and then you can start it again when you're ready. So I'll give you about 30 seconds for that. But if you need a little bit more time, just pause the video for now. Okay, looking at the first one, we know 1 fits into everything. If 1 fits in, 1 times what gives me 2? 1 times 2, so 1 and itself. The next one, again, we start with 1. 1 fits into everything. 1 times 4 gives me 4. 2 also fits in. 2 times what gives me 4? 2 times 2. I forgot to list my factors underneath. So 2 has factors 1 and 2. 4 has factors 1, 2, and 4. Although there are 2 of them, we only listed once. There are a few numbers that have these repeat numbers, but we just list them the one time. The next one, 1 fits into it, 1 times 5. 2 doesn't, 3 doesn't, 4 doesn't, so it's just 1 and 5. So 5 has the factors 1 and 5. Those are the numbers that fit into it exactly. 1 times itself. What else goes into 2 does? 2 times 4. 3 doesn't, 4 does, but we've already got it. And that's it. So the factors of 8 are 1, 2, 3, what am I writing? 4 and 8. For those who were a little bit quicker, let me just shift my page up a little bit. 16. What goes into 16? Well, 1 in itself. 2 fits in 2, 4, 6, 8, 10, 12, 14, 16. 2 times 8. 3, 6, 9, 12, 15, 18 doesn't fit in. 4, 8, 12, 16, 16. So 4 fits in. 4 times 4. And again, we only list it once. So 16's factors are 1, 2, 4, 8, and 16. Oops, we ran out of space. 13, well, 1 and 13 go in, and in fact those are the only ones that go in. So 1 and 13. We're running out of time a little bit, but I think we still have time for primes and composites. Prime numbers. So quite simply, we have a special name for numbers that only have 2 factors, 1 in itself. Jumping quickly out and having a look at our board, we can see that 2 only has 1 in itself, so that's a prime number. 5 only has 1 in itself, so that's a prime number. 13 only has 1 in itself as factors, so those ones in green are prime numbers. So we really just have a special word for prime numbers. Prime numbers are used in information technology for setting codes and algorithms and things like that, and they're also found in nature, which is really, really interesting. And if you've got the time and you are interested in that, go and have a look at where primes are used, where prime numbers are used. I have a little poem that I use to remember a prime number and what prime numbers are. And it's this, and it needs you to understand what the word factor means. So factors, the ones that go into you. So if my factors are 1 in myself, then I sit on the prime number shelf. In other words, if my only factors are 1 in me, then I'm a prime number. So if my factors are 1 in myself, then I sit on the prime number shelf. And composite numbers, very simply, are just all the other numbers. So if it's got more factors than just 1 in itself, then it's prime. So if we look back at our ones here and we switch to purple, we'll see that this one has more than just 1 and 4. So that is a composite number, and a composite number. So composite, prime. If it's got just 1 in itself, it's prime. If it's got more than just 1 in itself, and it doesn't matter how many, if it's more than just 1 in itself, then it's composite. Just enough time for a challenge. So I'll move my whiteboard. And your challenge is this. Circle, or in your case, write it down on a piece of paper, the prime numbers. So you may need to work some of these out. So I'm just going to jot some of them down all over the place. So have a look at those numbers, and I'd like you to, on a piece of paper, write down the ones that you think are prime. We're almost running out of time, so I think let's just pause the video now. When you feel that you're ready, when you've had enough time to go through and circle the ones or write down the ones you think are prime, then put the video on again. I'm just going to quickly give you the answers, all right, just to check that you're on the right track. So pause now, and when you've finished, then you can push play again. So I've already done 2 earlier on, so I know 2 is prime because only 1 and 2 fit into it. We did 5 earlier as well, so 5 is also prime because only 1 and 5 fit into it. Let's look at the next smallest, 4. We did 4 and we found that 1, 2, and 4 fit in, so that's not prime. 7, 1 fits in, 7 fits in. None of the others do, so that one's a prime number. 9 was our next. 1 fits in, 9 fits in, but 3 also fits in, so it's not prime. 11, 1 and 11 fit in, and that's the only 2, so that one's prime. 13, we did as well. 1 and 13 fit in, so that's prime. 12, we did, and we found that 1, 2, 3, 4, 6, and 12 fit in, so that's not prime. 15, 1 and 15 fit in, so do 3 and 5, so that's not prime. And 16, also not prime. Okay, so if you got those ones, then you're on track with understanding prime numbers. I hope you are. It's something that will come up a few times. If not, don't stress too much. There will be time to practice and make sure that you're up to speed with these. And that does bring us to the end of today's lesson. Please click on the worksheet above just to make sure and go through and consolidate what we've done in this lesson. A reminder that if you have any questions, you're welcome to email me at any time, grade4@worksheetcloud.com, and I'll get back to you with an answer. Or if there's anything you're doing in class that you want to spend some time on, you let me know and I'll see if I can put it into some future lessons. Have a fabulous day to my fantastic force. Goodbye.